In this video, we are going to discuss the distance formula in 3 dimensions. So if you look at the yellow writing, so back to 2 dimension, we have 2 points, right? The basic ingredient to sketch a straight line is you need 2 points. We have a point P, we have a point Q. We use a straight line to connect them, and the distance between these 2 points is you take the square root of x2 minus x1 square plus y2 minus y1 square. You take the square root of that, and then you find the distance. But in a 3 dimension, so in a 3 dimension, for each point, you have a x comma y comma z, right? So that means in the distance formula, you have to add one more components to it. So the distance, this is the notation we use P1, P2, then we use a symbol like an absolute value, but that is not really an absolute value. That stands for the distance between the 2 points. And then that is how we calculate the distance. So basically it's based on the 2 dimension. We add one more components to it, which is the plus z2 minus z1 square. Okay, so in this problem, would like to use the distance formula. I have 3 points. My question is this a right triangle or is this an isosceles triangle? So one thing that people would like to do immediately is they do that. I'm sure people do that in 2 dimensions. They will draw a picture and plot the point and then sketch the triangle, right? So in a 3 dimension, take my advice. Try not to, if not necessary, okay? Try not to sketch a 3-dimensional graph by hand, because if the points are off the grid, the work will end up with a piece of mess. Okay, so this one I will just draw a triangle like this, like that, and then I will call that a P, a Q, a R, and then for my reference. So first of all, I need to find the distance from point P to point Q. I'm trying to follow the notation. So start with a big square root. And then, so we use Q minus P, right? So that will be 7 minus 3 square plus 0 minus negative 2 square, and then plus 1 minus negative 3 square. So that is equals to the square root of 16 plus 4 plus 16. So we get nice numbers right here. The square root of 36, that is equals to 6. So this is equals to 6. And then the next one, the distance from Q to R. So Q to R, we use the formula again, so that will be R minus Q, right? So that is 1 minus 7 square plus 2 minus 0 square plus 1 minus 1 square. So that is equals to the square root of 36 plus 4 plus 0. So that is equals to square root of 40. So 40 is 4 times 10. The square root of 4 is equals to 2, so 2 root 10. So this will be 2 root 10. And then the last one, from R to P, let's don't use yellow, let's use white. From R to P, so we, from R to P, so we have the square root of, and then we have, so that will be P minus R. So the first one will be a 3 minus 1 square, and then plus negative 2 minus 2 square, and then plus negative 3 minus 1 square. So that is equal to the square root of 4, 16. So that will be 32 plus 4, 36. The square root of 36, that is equals to 6. So this will be a 6. I don't think that is a right triangle. So this one is already isosceles because this leg and this side and this side have the same measurement. So we can say that this is isosceles triangle. But if you want to say that that is a right triangle, you have to do a little proof. I don't think that that is going to work, but we can try. So we draw a right triangle, and then this is a 90 degrees, so that will be a 6. This will be a 6, and then this will be 2 root 10. So it's 6 square plus 6 square equals to 2 root 10 square. I don't think so. So 36 plus 36, there is no way that will be a 4 times 10, so that equals to 40. 36 plus 36 won't be equal to 40, so this is not a right triangle. So that is the practice of using the distance formula in a 3 in 3 dimensions. And that is also the end of this video. If you think my instruction is helpful and clear, let me know in the comment section below. Like the video, share the video for me, subscribe to my channel. I see you all in the next part. Signing off for now.